Alright, 2.1.3, we have b to the power 4 raised to the power 4 again. So in this example, we have a power inside the bracket that is raised to another power outside the bracket. So that's a power raised to a power, and we need to just simplify by using our laws of exponents. So the law says that when we have a power raised to a power, we are able to then just simply multiply the exponents. But before we just apply that law, let's just have a look at what b to the power 4 raised to the power 4 actually means. It means that this entire power that is inside a bracket will be repeated 4 times. So that's b to the power 4 times b to the power 4 times b to the power 4 times b to the power 4. And applying our laws of exponents for products with the same base, we've got the same base of b being multiplied with itself 4 times, or being repeated 4 times in this product. And of course, we then can add the exponents. So we have the same base being multiplied, so we can keep our base and we can add our exponents of 4 plus 4 plus 4 plus 4. And that will, of course, give us b to the power 16. Of course, we don't need to do this anymore because we have learned that a power raised to a power simply results in the two exponents being multiplied together. So I'll just say here, or we can say b to the power 4 in brackets raised to the power 4. That will be then b to the power 4 times 4, and that is equal to b to the power 16. Just note, I'm trying to just remind you all that a lot of the mistakes that you make with confusing the laws is that you tend to multiply the exponents when you are applying the product law, which is multiplying powers with the same base and then adding the exponents. As you can see, I've added the exponents there. A lot of you are still multiplying the exponents. So multiplication of exponents only happens in this case where I've got a power raised to a power, and I'm able to then multiply those exponents. I do not multiply over here. I add. Okay, so multiplication happens with the same base of b, and I'm able to keep that base of b and add all my exponents. But over here, I have a power of b to the power 4 being raised again to another power. So instead of adding all the exponents again, I can simply multiply these exponents over here and then get b to the power 16. So please note the difference between those two laws. 2.1.4, we've got negative k here in the bracket raised to the power 4. Now this is an example of one of the rules that we learned in laws of exponents, where we have a negative base. As you can see, this base of k is negative, and it is being raised to an even exponent. So our exponent here is an even exponent of 4, and a negative base is being raised to an even exponent. So in that case, we know that, well, I hope we know that our answer will result in a positive power. In other words, negative k to the power 4 will simply result in k to the power 4. You see, our answer has become positive, and this is because when we multiply out, if I had to take negative k to the power 4 and expand it, it would be negative k times negative k times negative k times negative k. And same base being multiplied together, or being multiplied, and we are able to then just apply the rules of multiplication when it comes to signs, and we've got a negative times a negative giving us a positive. So that negative and that negative gives us the positive. Then multiplying that with this negative again gives us a negative, and then multiplying that negative again gives us an overall positive answer, and that is why we are able to then conclude that when we have a negative base raised to an even exponent, because it will happen whether it is negative k to the power 4 or whether it is negative k to the power 12, any even exponent will result in a positive power overall. And that is, of course, then why we have an answer of just k to the power 4.